We've now taken a look at the three main programming blocks, which are OBs, FBs, and FCs. But let's look at them in a little bit more detail with an example, and let's talk about the best times to actually make use of them. So what we're looking at right here is we are currently in main OB1, so this is our top level OB. And I've got a new function block here called calculations. And this calculations function block has two inputs. It has system enabled and data. Just a little tip here, if you hover over the pin that is attached to the interface, it gives you the data type and also any comments associated. So we can see that that one's a Boolean and this one here is a real. So a value with a decimal point. And just for those who might have seen this from in other systems where you reference your own interface as the data you're passing in, you'll notice that I am referencing calculations DB, which is the instance data block associated with this function block, but I'm referencing it and passing in its own interface value. Now all that means is that I'm coming inside the data block, pulling the value out and passing it back in. It's effectively moving the same information into itself, but it does mean that when I'm running on a PLC, I can say modify and change the value without having to set up any additional data. Now, there are times where this is useful actually in sort of programming, and you might leave it like this and write to this somewhere else. But in most cases, it's not what you do in sort of production code. It helps you verify tests without having to create placeholders everywhere or use M registers. So I just wanted to explain that, why they're referencing themselves. But we will go through programming stuff in our next section. So let's turn that back on. And we're currently passing 120 into this block. So if I go inside here, we can see that we, inside our function block, have two instances that have different data sets inside our calculations function block of function block 1. And let's just pull the interface down and have a look. We can see here that we have system 1 calculations, which is a function block 1, and we have system 2 calculations, which is also a function block 1. But right now you can see that they have two different outputs on them because they aren't using the same information. I just make that small. We have a little bit more room. You can see on here that we have system enabled true on function block 1, system 1. But on system 2, we have system 2 calculations dot enable. So it's looking at its own value, and that value is set here. System 2 calculations enable when the output from system 1 is above 200. Now, I don't want to get too heavy in the logic because we haven't been through languages yet. And if this is the first time you're seeing ladder, it might not make much sense. But the gist of this is the output from our system 1 affects whether or not system 2 can run. And we'll see that in a second. But let's have a look inside function block 1. In here, we have 3 instances of function 1. And all function 1 is doing is really basic. If enabled, it multiplies the value that we pass in on data by a multiplier value and then outputs it on its return value, which is function 1, its own name. So we don't really need to have a look at that any further. And we can see it in action here. So it's true at the moment on the enable. We're passing in 120 and we're timesing it by 1. And the output is 120. And then you'll see the second instance takes the output from the first instance. So this one here comes down to this data here and is times by 2. And the same happens again. It cascades down from output 2 down to the third instance of function 1 and is times by 4. So we should see whatever we pass in doubled and then times by 4. So let's come out of this So back to here, we can see that we have two different instances of this. And if I open my calculations DB, which is the top level data block associated with the calculations function block, and just to expand these, we can see the two instances here. And if I go to monitoring, we can see that we have the outputs 120, 240, 960 on our first system 1 calculations instance. And on the second one, we have 0, even though we're passing in 120 because the enable is set to false. So everything that we've been through in the past few lessons regarding instance data and how you can have exactly the same function block with different instance data that behave in the same way logically, but can have different data outputs based on what they're passed. This is demonstrated here. Exactly the same sort of blueprint for the interface, but the logical outcome is different because of what we're passing in and the information that's stored within different instances. So let's make a change and we'll see what the outcome is. I'm going to change this value to 600. And then let's go back and have a look at the data block. So we can now see that system 2 has exactly the same output as system 1. And if we go into calculations and sort of check why, it's because they're both passed the same data and now system 2 is turned on. So if we turn system 1, if we change the value of data back below 200 and this isn't enabled anymore, what would we expect our instance data to do? Now, everything that we've discussed so far about things being remembered between scans, we would expect that this would be turned off on this enable pin, and our outputs would perhaps stay at their current values, retained within the static data of the parent object, our calculations DB. So what I'm saying is, when we turn off system 2 calculations on this enable pin here, this won't be executed anymore. And what do we expect these three values to do? So if I go ahead and modify this to 100, and we go back and have a look at the calculations data, they return to 0. And this is an important sort of example of how memory works when you're using functions. So if I come back to calculations, we can see that we're false now. So this isn't executing, or sorry, the enable pin is set to false, but the function block enable is still true. So we can see that from the left-hand side all the way through, this instance is still enabled to run. So if we come inside function block for the system 2, and we monitor this one, I'm just going to change it to system 2 because it will default to system 1, and we'll cover this sort of stuff in lessons coming up. We can see that although enable's false, that doesn't actually stop the function from running internally because the en for the function is still enabled. So we output 0. We come into this function and have a look what happens. Enable is off. Enable is off, and because enable is off, function is never updated to a value, but because it's a return value, it will be passed out as 0, which is the default value for a real. So we end up with the value 0 being passed. And that's because functions do not retain any information between scans. If, however, I turned this off here, so our enables were all moved to this point here, so we don't execute the function at all, we'd have a very different outcome. So now we can see that we aren't executing these functions at all because the enable pin is not set. And you can see that we don't even get an output coming out of these return values either. Like nothing is monitored because this has never been executed since we've been looking at it. So now if we repeat the same test, let's just have a quick look at calculations just to verify what the output values are. We can see that we've got 100, 200, 800, which is our expected outputs for system 1. But system 2, we've got 0, 0, 0, because it hasn't executed yet. So let's go ahead and change our data back up above 200. So I'm going to set it to 300 again. Sorry, it was 600. We'll set it to 600. Come back into calculations. And we can see that both systems are active and produce the same output, which is what we're expecting. If I take this main data input here below 200 again, back to 100, we got 0 last time on system 2. But this time, it retains its previous values. And if we have a look why it retains its previous values, I'll just make sure we're looking at system 2 calculations. It's because these functions are not executing. But now, if we have a look at calculations DB, these output values are retained in the instance data. Because nothing's updating them, they simply just stay as their last known value. So hopefully what you can take away from this lesson, and I appreciate that we haven't been through all of the fundamentals that are used in this video. There is still further learning to sort of digest and bring yourself up to speed on, and then maybe come back and watch this one again. But hopefully what this demonstrates is, depending on how you use function blocks to retain information and how you use functions and when you choose to enable functions, it makes a big difference on how your data is worked with, how it's retained and remembered between scans, and ultimately gives you greater depth of control by mixing different objects. Something that I just want to touch on before we sort of finish the video or finish this lesson is this is an example of what we spoke about in both the OB lesson and the FB lessons, which is a top level function block. We can see that although we are passing some parameters in, the interface for it is fairly minimal, and its main purpose is to simply house information or static data for everything that's happening inside of it. So we make a top level call to calculations. Most likely it will only be used once, and inside here we write logic that is relevant to that area. And we can create all of our function blocks within this space using the static data of their parent, so we don't end up with lots and lots of singular data blocks for functions that are, or function blocks that are called inside another function block. So again, I hope that makes sense. Quite a big lesson to take on board, but if you do have any queries, then write a comment in the comment section below, and I'll do my best to answer those.